planning with us, so take great advantage of that. So,
hey, Greg, good to see you. So, yes, yeah, we didn't give you enough time for that exercise. And next time we do it, we will spend some time going through some of those tools in a little more detail so you have a better idea what you're looking at. And next time we'll have a prize. We'll keep track of the forecasts and have a prize for the best forecast. So y'all did the, well, I haven't checked if you all have done it, but hopefully all of you did the pre-course assignment. And I just want to take a minute or two to see what you thought and how well the models did, in terms of the input elements for the HDWI system, temperature, RH, precipitation, wind speed, and any surprises or, just general impressions. And you can put it in the chat, or if you want to do it vocally, that's great too. Thoughts? Waste of time? Learn anything?
I'll raise my hand quick, I guess. This is for the pre-course, like the weather of the 3 different locations.
Yeah.
Personally, I found it was a little hard to judge because of like minus temperatures and that kind of humidity that was 100%. It was a bit harder to be like, oh, which one is good, which one is bad, just because there was such a small variation there, especially for, I'm not a fire behavior expert, but I was like, -1 or -3 is like, it's not a big deal there. So I wasn't sure, like, as we get closer to like fire weather, it might be easier to judge.
Okay. Yeah, it's not exactly fire season across some of those locations, though we did have fire in BC on the weekend. Lumbee had a 3-hectare fire. Any other thoughts? Yeah, Jay.
Yeah, for the assignment, I found that, just taking one snapshot in time was just not a great sample size for just comparing the models, and that's why I was curious what other people sort of found. And with the dates I picked, I kind of hit some record temperatures in BC and that sort of thing too. So it was, I liked the exercise. I just thought I'd like to do it over a longer period of time to really sort of find which one worked best. For the dates that I picked, the North American model did better than the others. I'm curious now to reflect back based on after our talk this morning too, and just look at the models in a little different view, thinking about elevation and because I hadn't really thought about that piece the way Matt had brought that out, with the resolution and elevation. So yeah, that was my thoughts.
Yeah. Yeah, the elevation aspect is a critical aspect, especially with some of those grid cells being so huge that, if you're anywhere near the sea level, it gets complicated quickly. But, for me, okay, Shelley.
We're not hearing you, Shelley. Are you muted on your end?
Oh. No, it's my mic. I always put it
there
up. Sorry, do this all the time. So I found it interesting for the I was wondering if it was a transitional, because similar to what Jay said, like the day I picked, it was all over the board. I actually couldn't pick a clear winner, but I was wondering if the transitional seasons of fall and spring made a difference in the models to narrowing it down, that with having the weather fluctuate as much as it does in the spring and the fall versus kind of in the heat of the summer, you kind of everything's starting to get into a pattern. Anyways, I wasn't sure if that was a thing or not.
Well, it is a thing. You highlight something. Transitions are the more challenging forecast situations, and there's more variability in the spring and the fall compared to summer, but there are transitions in the spring and summer during fire season, frontal situations being that, or ridge breakdown being another example. So, I'd like, in future, I would do it for a few more days, which would be more useful for the planners, than the tactical, where's the fire going to spread in the next 24 hours. But, even at this short period, the models, depending which days you chose, they weren't perfect. Okay, in some cases they weren't very good. Okay, so that's part of the the take-home message is models are models and they can be wrong, and yeah, and that's why we think having that big picture is very helpful at times rather than just running with spot, okay, or windy or whatever you use. Okay, I'm going to share my screen, and Dan or Dana or Kelsey, can you monitor the chat for me, because I'm just working with a one screen laptop, and yeah, I'm debating. Okay, so for this hour, I was going to go through some of the questions. I really appreciate the questions posed. They were great. But I want to talk about hot, dry, and windy, but maybe I'll try and roll through the questions first and then come back to hot, dry, and windy if we have time. I've put my PDF of my presentation in the module, so the links are there. But anyway, let's roll and see what happens here, okay? And I opened a few more windows. Now at 38 windows. Here we go.
Careful you don't crash the whole thing, eh, Mike?
Oh, I usually run 100 windows. So.
All right, there we go.
So let's skip the hot, dry, windy, pop into some of these discuss, and I'll go from current slide. Okay. So Dan actually posed this question. I get this a lot, and I see a lot in social media too. And actually, Matt wrote quite a detailed answer. I agree with his answer. It can be a factor. I don't see it being a primary factor, but it can play a role. And the reason, ENSO, El Nino Southern Oscillation, affects global climate. Absolutely. But the biggest impact is winter, which is not our fire season. And someone pointed out, I think it was Brett, lags are important. I see people on social media doing a simple exercise comparing current time period to, current fire weather activity to current, El Nino. And, they say, oh, we don't get anything. Well, the lags are really important. You have to do the lag. How strong the El Nino is. This one was about 5th strongest since about the 1850s. And the graphic there shows March to May temperature anomalies for the 8 strong El Nino years since 1950. And this is from Brett Reichsteiger from Alaska. And he's always doing great graphics. And you can see, based on this, I'd be worried for Alberta. Okay, and the last super strong El Nino was 2016. And of course, Fort Mac happened. But you'll recall that there was flooding in June too. So, but I think, the SSTs, sea surface temperatures, they do impact where the highs and lows are. And they, there's a lot more thermal inertia and there's ocean currents. So things don't change as rapidly as they do on land. So I think there could be potential for reliable fire season forecasts, using sea surface temperatures. So, I see it as a factor, but not the primary factor. And, if you haven't read Matt's detailed reply, take a look. Okay? It's a good reply. I do want to talk about blocking ridges. And, this is nothing new. You folks and researchers have known for 60 years, 70 years that blocking ridges are conducive to fire. And by blocking, we mean stagnant or semi-stagnant for 7 to 10 days or longer. The omega block we talked about earlier this morning, and you can see this off, northern BC, Yukon. You can see that omega shape. There's also something called Rex block, where you have a low pressure to the south and the high ridge to the north. Omega is much more common. And all this does is, the steering flow is directing low pressure systems that carry the precipitation to the north, to the south, and keeping that air that where the ridge is, and the ridge is kind of like the opposite of your grade 3 water cycle. What grade 3 water cycle, air rises, cools, condenses, forms clouds, rains. The ridge is air sinking, warming, drying. So because it's subsidence, it means you're generally sunny, generally warm or hot and dry. And you folks know that on hot, dry, sunny days, the DMC bumps up 3 to 5 points a day. Okay, so if you get 7 to 10 days, even if your DMC was near zero, it's going to be dry enough to support lightning ignitions. And FFMC is, 2/3 of a day for time lag. FFMC's ready to roll fairly quickly in that time series. Now, eventually the ridge breaks down or shifts, and this is often gives rise to a frontal passage. Typically cold fronts, as we talked about this morning, cold fronts are critical in many areas with respect to fire activity. There's also things like shortwave troughs, and so within this larger flow in the 500 millibar, you get little ripples running through. I guess you might consider a roller coaster as the main flow, and the cars going on the track as a shortwave. Basically, it's just cold air aloft that's causing that pressure change, giving that little trough. But that cold air aloft means it's much more unstable, which leads to thunderstorms. And so even though you're in a ridge situation, you get one of these ripples come through, shortwave troughs, you get a lot of lightning activity. If the fuels are dry, away we go. So these are some of the reasons why blocking ridges. And if there's any questions, put them in the chat and I'll try and answer them. I don't see them, but Dan or someone will flag them for me. Pyrocumulonimbus. Okay. I mentioned this morning, BC had over 50 last year. The Canadian record was 50 in 2021, and the global record was 100 in 2021. And as I mentioned, Canada had about 140 last year. Precursors are PyroQ or PyroTCU, towering cumulus. And you can see in this GOES picture, this is a visible. These are actually pyro-CBs popping, but as soon as you start, the gray is smoke. As soon as you start seeing white cloud, that's cumulus. So if it's just a little baby, it's a Q. If it's starting to show more vertical dimension, and you can see shadows from some of these, that's TCU. And when they get to much larger, brighter, we can also look at cloud top temperatures to determine, how high up these are, to say if it's a CB. You can look at lightning data, you can look at radar, but satellite's a pretty good way of determining where these are. Instability somewhere in the sounding is usually key. Inversion strength is an issue. Inversion depth. Can the fire punch through? Is it intense enough to punch through that with the column? Wind speed's really important here. If it's really windy, it tilts the column, okay? And it's not nearly as energetic to get through inversion or to punch higher. So just something to keep in mind, that pyro-CBs often happen when winds are light. And so, our fire danger rating system it's great, okay? But it really is built for wind-driven systems rather than column-driven fires. And so you really have to be careful with these column, these pyro-CBs. And the combustion process, we all know it releases heat, but a lot of people don't realize that in the equation, moisture is also a byproduct. So it's pumping hot, moist air, and as it rises, it cools and condenses back to our grade 3 water cycle, and away we go. So I think drought's playing a role, and this is an area of active research looking at pyro CBs to see if we can get, and there is already some pyro CB forecasting tools developed in Australia. But this is an area of active research because, we are starting to see more and more of these, and with the changing climate, I think we may continue to see even more.
Mike, you got a question from Ryan.
Okay, go ahead, Ryan. Or do somebody read the question if it's straightforward?
Hey there, I was just referring to the shortwave troughing in a high pressure zone in the Omega Block. We saw a lot in northern Alberta, southern Northwest Territories, in the wood buffalo area this past season, where it'd just be Omega blocking, and then this repeated cycle of weather forecasts calling for rain, thunder showers, and we knew just by the second or third time that this happened, we weren't going to see any of the precip, but we were going to see wind shifts and potential for a little bit of precip with lightning coming down. I'm wondering if that's kind of what an example of that would be in like real world application.
That's exactly what you're seeing. So the ridge stays there, but these little short waves ripple through the position, and as they do so, they develop in thunderstorms, sometimes dry thunderstorms. That's the no precip or little precip. Yeah. And the winds pick up, and it's like a mini front in a way, and then it passes through, and then 24 to 36 hours later, you may get another little ripple come through, and it can be just a series of these, as opposed to the whole ridge breaking down or shifting off. Okay, so that's exactly what I'm talking about. And the way you can find these is in the 500 millibar. You look at the temperatures or the vorticity. We'll ignore the vorticity because it's a pain in the butt, but temperatures are pretty straightforward. Where these little pockets of colder air, 500 millibar, and sometimes if it's a strong enough shortwave, you actually see a little dip in the contours, like a little trough, and if you put it into motion, you can see these things ripple through, and they can be a real problem. And
conveniently just landing on transition days every time.
It seems like it's a non-ending series of transition days. Yeah, it's just a challenging situation for fire people, especially if there's already fires on the landscape, and because there's potential to add new fires and the strong and shifting winds that come with these often. So.
Awesome. Thank you very much.
Okay. One of the questions was about when do we know when a fire will run? And, I think originally maybe it was in respect to darn smoke. And yes, and I think Matt partially answered this in the discussion. Smoke is a pain in the butt, and we have lots of smoke models. There's fireworks, there's blue skies, and there's others. Unfortunately, at the first couple of days with a new fire, they're not very good. I'm sorry, I don't mean to offend any smoke modelers, but they're not very good. Okay, but this is where satellites can help us. So the smoke, if it's of any significance, does show up, and 3 degrees, 5 degrees. Of course, it affects RH. I'll try to avoid my rant on RH, maybe for a little bit, but yeah, it does affect. It makes it much cooler, and you folks in fire have seen similar days in terms of FWI system. One day's sunny and one day's cloudy, and the sunny day is much more active than the cloudy day. It's because on a sunny day, those fuel elements are much higher temperature than they are on a cloudy day, even though the temperature in the screen is, the weather station's very similar, but smoke is even cooler, and you don't get the solar radiation that's thick enough, and you get a real problem. Now, I was glad to see that in some of your Canvas stuff, it had some of these references. For spread days, traditionally ISI, 8.6, 8.7, FWI of 19 thresholds. But these do vary seasonally and regionally. There's a paper by Li Wang and others, and looked at some of these seasonal and regional variations. And they also looked at FFMCs, and FFMCs of, you can see the plot here, hopefully. But FFMCs of around 90 really start to say, hey, the percent is really high. And which, as you guys all know, means a moisture content of 10, 11%. So the fine fuels are really dry. All right. Inversions, and I'm going to show you some stuff about inversions shortly. Inversion breakdowns, there are models for this now that can help you, because once the inversion, it's just traps stable. Winds are usually really light. The smoke is trapped in there. And once it breaks down, the mixing, those winds we look at from above can start to mix down to the surface. And that's when the fire can wake up and start moving. And the backdrop too is drought. Okay. If we have a drought, things seem to be easier to get rolling than if you don't have a drought. Once again, persistence forecasting. If you're in the same air mass and it was a good spread day yesterday, chances are it'd be a good spread day today unless something's changed. And that's same persistence forecasting for inversion breakdowns. If it was broke down at noon yesterday, at same air mass, it'll probably break down around noon today. Inversions. Okay, so I took this a couple days ago from Prince George, and how shallow is that? That's quite shallow. Okay, and in summer that would break down really quickly, but we're not summer. So the sun angle's low, day length's not as long as summer. So when will this inversion break down? Will it break down? Okay, and anyone hazard a guess? I would tell you it was pretty sunny. Okay, so cloud's not playing a role. You can see on the right hand side the lifted index is 12 as a value of 12, which means it's pretty stable. But you can see the winds on the barbs on the right of the skew long TP, and you can see the winds are almost nothing below it in the inversion. But once you get above the inversion, it looks like 15. And these are always in knots, or should always be in knots, as opposed to kilometers per hour. So anyone hazard a guess when this, as I said, this is just from a few days ago. When do you think the inversion would break down? Ballpark. Take a shot. So just to make sure we're clear, for some reason, I can't get my cursor to move on to the tetragram, or the skew on 2P. By inversion breakdown, see that curve, that dark black line on the right? That's the temperature. And once that bottom line moves to the right of, where is it, about 940 millibars, and goes at right angle to the surface, that's when the inversion breaks down.
We got a couple guesses in the chat, Mike.
Good.
Aaron suggested 15. Andrew and Anne-Claude and Jay all suggested 12.
Okay, good. Now, if this was summer, I'd say it'd be 11. But since it's not summer, and so I took the weather, okay, and from that day, and it seems like between 12 and 1, it looks like she broke down, okay? The temperature started rising, and I can go back to the vertical temperature profile there, but the winds is really what, they were south 5 east, so bouncing around light, and then jumped up to 13 kilometers per hour at 1 o'clock. And so I'd say broke down between 12 and 1. And, so if the next day, if it's the same air mass, I would expect it would break down between 12 and 1. Now, whether that's a spread day or not, that's, depends on a whole bunch of other factors. But
I should note we did do, sorry to interrupt. I should note we did do an exercise on this, but we're using fairly simple thermodynamic diagrams that are a little easier to read rather than the TEFIs. So I think there's some good concepts understood, but the reading the TEFIs is not something we went over. So that's.
Yeah, I think, I know you're not forecasters, but TEFIs, long skew TPs, they are really useful. And in some of the earlier weather courses you took, was this covered in any detail? Because I really think it is an important tool. And once you understand it, it's a very useful tool. So students can tell.
I don't know if Dana wants to jump in. I mean, what we have is there's a kind of a macro spreadsheet that grabs the University of Wyoming sounding and then just displays in a much easier to read format, one graph for temperature with elevation, one graph for RH, one for wind and stuff. And so, it's pretty clear and then the exercise was to draw the line, where you see you can follow the adiabatic lapse rate and predict the breakthrough temperature. So, yeah.
Okay. But I guess my question now is, when you took 290 or 390 or any courses like that, whether they talk about TEFIs at all or not, if that's part of the curriculum?
Most of the time they stick with the TEFI. The skew T is, I think, for the layperson is a bit confusing to follow kind of those skewed lines, and where the TEFI is more straightforward. I think that's where we went with it. We just stayed right with the Excel TEFI, and everybody did well when they were asked to look at a profile and give a temperature. Everybody was just about bang on.
Okay, good to know. And Dana, you did send me the tool, the Excel sheet. Yeah. Okay, so I'm going to go talk about something new here. All right, at least for some of you. All right. This is the hot, dry, windy index. And I've been using it for a few years, and it's not to replace our FWI system. It's just another tool in the toolkit. And I find it works really well with wind-driven fires and fires, that dry out quickly. So it's got zero time lag. Okay, so which is interesting, and all it is every hour it takes the multiplies the wind speed, meters per second, multiplied by the vapor pressure deficit in millibars or hectopascals for 3 layers at the surface, about 250 meters above and 500 meters above the surface. So by doing that, it gets a little bit of that vertical dimension, and in particular the wind, all right, above, getting away from the surface to a more potentially realistic wind being observed by the fire once the inversion breaks down, or if the column is able to drag those winds from aloft down. So it adds that element. It takes the max of each element from each layer and multiplies it, and then does it for every hour. And, I have one student, Kyle, who did his master's looking at the same fires that Cordy Teamstra did, for looking at what escape fires, and the cold fronts were about close to half, the southeast winds were about a third, and then there was a whole bunch of other things that came in after that. But he found on those escape fires, hot, dry, windy, these are May fires in Alberta, It did really well. So this is, here's a map of, and there is Alaska as well. So you can get the Yukon, but areas of Northwest Territories, I'm sorry, it's not available for you yet. And so, right now this compares observations to climatology. And, Brett, if you're out there, I think doing something like this for ISI and FWI and other FWI variables would be very useful. I'll show you what I mean in a second here. So here's a location not too far away from Osoyoos, but and it shows the history in the last 10 days, what the value was, and it shows you the climatology, and these are 30-year climatologies typically, and then it shows you ensemble forecast for what the future may look like. And there's above 95th percentile on day 3 there. A lot of the ensembles are up. There's a couple that dip down, and that's how ensembles work. But if I was sitting and planning, I'd say, today, the 17th, it's 95, 90th, 75th. Yeah, it looked like a potential for active, but definitely day 3 is the one to watch out for, and possibly day 6, but I'm not as concerned about that as day 3. So another aspect of this is it gives you aerial coverage of different percentiles for the forecast period. So by that, I mean, so day 0, it shows you this map of North America, or a good chunk of North America, and what's above the 75th, what's above the 90th, and the number of ensembles above that 90th percentiles and 95th percentiles. And it does it for day 0, day 1, day 2. I'm not showing them all here because, I just wanted to give you an example of what's going on, but I see no reason why this can't be done with ISI, FWI, FFMCs, etc. It just puts things in context historically for that location and date. So I see this as very useful, and maybe if we take 5 minutes, and I could put the link in the chat. I'll stop sharing for a second here. Okay. And maybe you can go take a look at Osoyoos, or as close as you can get to Osoyoos, and see what HDWI does for you. Just give me a second. I'll pop that in the chat. You can. And they have a new home now. So,
I'd probably just jump in with your question there, Jay.
Hey, Michael, I just have a question with this hot, dry, windy index. So it uses the data from climatology from 81 to 2010. At what point are we seeing stuff from 2010 to 2024? Like, you kind of work in that data space. Is it statistically still, quite accurate?
So I imagine they'll update. Climatologists like to use 30-year periods. There's nothing special or magical. It's just 30 years. They like to use like 81 to 2010. The 91s to 2020s are out. Many of the agencies or many of the organizations like WMO, NWS, ECCC are now using that 30-year baseline. I expect hot, dry, windy will update theirs as well. So yeah, we are seeing warmer, drier conditions as we move along. Yeah. So it'd be nice for them to update it, because the percentiles will change as we get warmer and drier. They get higher and higher. So yeah, but it's still a relative trend indicator of what's going on. And I put the link in there. So that long of soils. Boy, spelling. 49.0323 north, 119.4682. So 49. What we got here? So
Mike, you're not sharing your screen.
Yeah, I was hoping people would do it themselves, but let me do this, okay? So just have to find the window that's on. Okay, hopefully you can see my screen. What did I say? 49 and yeah, that Let's stop sharing. Trying to move this toolbar out of the way. Well, we'll use this as an example because I'm having trouble moving this. And you can see it's not that bad for this location for this time of year. And, you know, the actual HDWI value on the left-hand side, in summer for these locations, probably 100, 200 in that area is what you would normally see during the fire season. So these values are fairly low because it is March, okay? It isn't typically, you can see later on, you know, in the forecast period, some of the ensembles are starting to show some indication towards more, you know, potential for spread, or, you know, hot, drier, and windier than, you know, current day, but it's pretty quiet. Yeah. So
you're explaining that this is the wind speed times the dew point, is that right?
No, it's the wind speed times the vapor pressure deficit.
Oh, sorry. Right.
Okay.
Right.
So, and maybe I'll take a minute here. My problem with relative humidity is that it's relative. Okay. Now, this doesn't mean that WI system doesn't work. Because it has temperature and relative humidity, it works well. Okay. Vapor pressure deficit really is the physical process of how strong that gradient is at sucking moisture out of dead fuels. Okay. And live fuels, but live fuels have stomata in their leaves that shut down so they don't lose moisture, whereas dead fuels don't have that capability. Things just get sucked out of them. And so you can have a situation where the relative humidity is the same value, but your vapor pressure deficit is twice, you know, a factor of 100% more than one case. And it's because as temperatures rise, this vapor pressure deficit potential increase is exponential, not linear. So it gives you a better indication of what's the drying power of the atmosphere. And it basically combines temperature and our RH into one factor, or you can go the other way. Vapor pressure deficit can give you temperature and RH. So it's very quick reacting, and, you know, for grass, for other things, it does a good job. BC's been using it kind of for the last couple of years. I've been using it for about 4 years, and, you know, I wouldn't use it Pyro CB, but anything else, yeah. So let's see comments. The beer, what?
Lori's from Newfoundland. She noticed that the HDWI chart cuts off the north, as you noted, but also cuts off Newfoundland. So
sorry. I thought there was some Canadians working on a Canadian product so that we'd have more complete coverage. Yeah. But,
yeah, so when I was talking about new tools for fuel treatment stuff, there was kind of got in a little bit to the notion of the FFMC is calibrated for closed pine stands, and when you have open stands and when you have open fuel types like grass shrub, because in the FPP things are correlated with the ISI, it's not so much the index that's the problem, it's the rate of change is the problem. And so that's kind of like what you're getting at. This index changes much quicker than the FFMC. Presumably it doesn't have anything to do with actual calibration to litter content under a conifer stand. It's a physical math kind of equation, right? So that's I think the nuance maybe that you're getting at.
Yeah, it's more like the equilibrium moisture content, EMC, is probably
right.
The closest thing I can. So here's the HDWI probabilities, and day 0, there's some stuff to the south of Osoyoos, and there's a little bit in northern Alberta showing up at 75th percentile, but 95th percentile, there's not much. Day 1, day 2, day 3, you start to see some stuff in Alberta, a little bit more in Alberta, some in BC. Mexico looks like it's got some conditions right. Day 4, day 5, and there's day 6, there's some stuff showing up in Quebec at 75th percentile. So I like these types of maps. I think they're very informative. If you're on an individual fire, maybe it's not this tool isn't so great, but in terms of because it's such a large spatial area, I would use that, the clickable plot that I showed you earlier is what I would use. But this is something, it's freely available for most of Canada. I'm sorry, and if I go back here, let's see what we have. Alaska here. Oh, there's some stuff showing up in the North Shore there. You can see, you get part of Yukon. You don't get all, but yeah. But I'm going to click here and see what the values are. 10, yeah. Well, interesting. 70 north. Wow. Okay. So take a peek. Play with it. It is just another indicator of of conditions that are right for spread. It's partly because it doesn't have the equivalent to FWI. Well, they have ERC, which is so yeah, maybe. I mean, in the jargon of fire weather people, we've always, before there was an index, we always said hot, dry, windy. So somebody just developed index to capture those hot, dry, windy days, which are often those problem days. So yeah, I think I only have like one more slide left to show you, and then I will open up the floor to any last comments or suggestions, etc., etc. I almost clicked on the leave button instead of the share button because they're right beside each other. They should not do that. Okay, I'm going to do that sometime. I have a cat that comes up, and when I'm at home, I have a touch laptop. Sometimes I love it, sometimes I hate it. The cat will come and rub his chin on the top corner, which closes wherever I'm in, which is Teams or Zoom or whatever. So anyway.
If you don't mind, another question from me here, just on this HDWI, like, something like the FWI, which we're all familiar with, you calculate from weather readings, right? Like, so we all know the open clearing with a weather station with the anemometer at 10 meters and the screen at whatever it is, 1.5. And that's all you need for your FWI calcs, right? Your bookkeeping, day to day or hour to hour. But this one is interesting because you said it's got 3 different layers of calculations in the atmosphere. So it's kind of a mix of observations, because some of these would be from the weather balloons, but then also reanalysis, right? Interpolations between the the atmospheric layers. So I don't know if you want to comment on that, if I have that right.
Yeah, you have that right. Yeah, so I mean, if you have an upper air station, you're good to go. If you don't have an upper air station, then you have to use model data, okay? And that, or, you know, to have it automated like it is, you can't use things like helicopters or aircraft that you could use in the field to kind of get it going, but to develop that site, they use model data, okay? Which, as we talked about this morning, you have to take some salt with model data as opposed to observations. And that's a limitation for sure, yeah, because model data can be wrong, and so you're getting an incomplete picture. So, you know, I'm always interested in seeing pictures from fires, and some of them have been posted on Canvas, and that's great, thank you. Questions? I like to think Matt and I and others, you know, like there's some great weather forecasters across the country. I think they're all open to questions about, you know, how, you know, questions from the field, you know, what you saw, you know, what if there's things you don't understand. Talking to Matt, I think we'd like to put a site with a list of all the websites that might be of use to people in the field. And there's tons. I did one about 8-10 years ago, and it's out of date now. Okay, I mean, there's a few of them, like the Wyoming site are still there, and a few others, and some of the satellite sites, but there's a lot more information available on site. It'd be nice to have kind of key points or descriptors, a write-up on how to use it. That's a little more involved, but even just having a listing, a directory of useful fire weather forecasting sites, it would be of value. And I didn't answer all the questions. Canvas stays up for a while, and Matt and I will probably try and answer some of the questions I didn't get to, but, you know, always glad to talk to people in the field about fire and weather, climate, what have you. All right. So I think that's where I'm going to stop. I don't have any more pictures of pyro CBs, I don't think. So.
Any final questions for Professor Flanagan? Sorry. Oh,
Mike, please.
Trying to be respectful. Sorry. Anyway, Mike.
I know. Just
final questions for Mike from anyone out there. We'll probably take 5 minutes before switching, but this is a good time. Yeah, go ahead, Matt.
Mike, thank you for this presentation. It was good. One thing that I struggle with in the field, and there's probably general rules, and I've probably missed it with multitasking, but just thinking about smoke and the effects of the relative humidity from smoke, the temperature from smoke, even the influence that it has on wind, because the surface temperature is not going to be the same. What kind of general advice, recommendations, thoughts, ideas, you know, if I have another fire that's 20 kilometers away, it's got the shadow aspect, what kind of other things, you know, can I think about how to change that temperature? I can't necessarily get a machine out there to get up in the atmosphere, you know, up 10,000 feet to do temperature stuff because of visibility, but it impacts. I've been burnt so many times because this fire is going to go, and it doesn't go. And why doesn't it go? It's got everything there. Everything is there, but it's not going. And yeah, I'm passionate about this because I've had my ass handed to me over this one, and I just kind of want to figure this out in a meaningful way.
So weather forecasters and fire behavior analysts are similar in that they get their ass handed to them regularly, okay? Despite our best efforts, and there could be lots of reasons, but I'm going to stick to the weather. I mean, for fire, it could be, you know, something, the fuel's not correct, the fuel moisture is not correct because where the weather stations are, where the convective precipitation hit and things like that. But, you know, if you're using, you know, Prometheus, or if you're using just to calculate the indices, in Red App or Excel sheet or whatever you use, knock the temperature back, okay? And, you know, if it's really heavy smoke, it can be 7 or 8 degrees Celsius. Okay? If it's moderate smoke, 3 degrees. Adjust the RH accordingly with those cooler temperatures. Lower the wind speeds. Yeah, I know you don't want to get caught off guard and say, "Oh, it's not going to spread today," and then it does spread. You know, that's even worse than saying it's going to spread and it doesn't spread. Okay, it's a different kind of ass serving being served up, but it adjusts, you know, and take a look at yesterday. If it were smoke yesterday, you know, how did it do? You know, I'm in Kamloops, and there's been days when the public forecast says it's going to be 32. The smoke rolls in, and we get to 26, 27. It's a completely different day. And that solar radiation part, yeah. So, you know, use what happened yesterday as a, you know, if you can. If the smoke is new, well, then, you know, adjust. But it's a moving target, and it's challenging. Use the satellite. Okay, satellites, especially the GOES, is updated every 10 minutes, and you can see smoke on that. You know, for those that don't use satellite, start looking at it every day. You start to see patterns, and you start to get really good at saying that's cloud. You know, that's fog, that's cirrus, high level cloud, that's smoke. Okay, and you know it gets to be second nature. So satellites will show you where the smoke is spreading fairly quickly. Yeah, it's challenging. It's
No, that's even valuable. Just even hearing, you know, like the different levels of smoke, which, yeah, you do see that. But even thinking of the baseline, like use 3 degrees and 7 degrees, yeah, and you can mess around and analyze what worked, what didn't work based on those conditions. But that's good hearing those general values overall. So
those are ballpark and
ballpark guideline, general, yeah. But it's just good starting points. Thank you.
Yeah, and if you have time, you run different scenarios. Take 3 degrees off, take 5 degrees off, take 7 degrees off, and see how sensitive your day is with your current conditions for spread or indice values, etc.
Awesome, thank you. Yeah.
Other questions out there? Oh, you're looking at that.
Persistence is really good. The trick becomes, and same for Pyro CBs. If Pyro CB did something yesterday in terms of spread, Kelsey, and you know, today is a similar day, that's a good starting point. You can adjust it, you know, as need be. Well, folks, I've really enjoyed this, and great to meet some of you for the first time, others to get acquainted again, and we'll try and go in Canvas and answer those questions we didn't get around to. And my email is mflanagan@tru.ca, or just put me in a browser and I should pop up somewhere. Okay, so
I think your email is on your profile in Canvas too. People can go there and find it. So
good. All right, great.
Thanks so much, Mike. You're welcome to stick around if you want to hear Greg Walker talk about the role of the F-band in ignition ops. I understand if you don't. And students will be encouraged to contact you as they wish. And otherwise, for the class perspective, I think we'll take 5 minutes and come back at 5 after. But thanks again to Mike.
Yeah, Greg. Planned ignitions are the best way to get back on the landscape, as far as I'm concerned. All right, thanks everyone.
Thanks, Mike. Appreciate it.
Bye.
Bye-bye. And I will stop the recording just to split it again. So yeah, we'll